Moving on to volume of spheres and hemispheres. Okay, first of all, the formula for a volume of a sphere is a much more difficult one to visualize, so we're not going to really do that. I'm just going to kind of give it to you, and here it is. The nice part about this, it is given to you on your reference sheet for your exam. You don't have to memorize this, just like all the other ones. They will be given to you. It's 4/3 times pi times the radius cubed. We only have one dimension for a sphere. A sphere is like a ball, you know, a ball shape. I think we all know what spheres are, but it's a ball shape, volleyball, basketball, whatever, okay? But all there is a radius. Think of the very middle, the inside of the sphere to the edge, to any edge. And that's the radius of the sphere. That's all we need. A hemisphere is 1/2 of a sphere. Okay, so it says that right here. A hemisphere is 1/2 of a sphere. So if they ever say hemisphere, you're just going to do the volume of a sphere and then cut it in half, divide by 2. So some examples here. Determine the volume of the solid below. Notice how they say this is congruent. See the little congruent mark? So that means the height of this cylinder is also 6. So what we have here is we have a cylinder. We got a cylinder and then we got a hemisphere. So to get the whole solid, it's going to be the volume of the cylinder plus the volume of the hemisphere. All right, volume of a cylinder plus the volume of the hemisphere. Well, the volume of a cylinder, we should know from a previous lesson, is pi r squared h. And the hemisphere is going to be, just like, you know, from above, 4/3 pi r cubed. And then we're just going to do half of that. We're going to do half because it's a hemisphere. It's a half of a sphere. This is a sphere. Hemisphere is just cut it in half or divide by 2. All right, so this is going to be, this comes out to be, let's see here, 6 pi times 6 squared times 6, and that comes out to be 216 pi. I'm going to leave it in terms of pi. 6 times 6 times 6 is 216 pi. And then plus, and then this comes out to be, well, I did divide by 2 instead of half. I did divide by 2. So I got 288 pi. Oh, sorry. 4/3 pi radius 6 cubed. And then divide by 2, and that comes out to be 288 pi over 2. Of course, 288 over 2 is 144, so it's 216 pi plus 144 pi, and then I add those together and I get 360 pi. Now that's in terms of pi. It didn't specify to do it in terms of pi. I just left it in terms of pi. If they want nearest tenth or nearest hundredth, you just type 360 pi in your calculator and you get the decimal approximation. It's always easier to do that. So I always leave it in terms of pi unless they tell me otherwise. Find the volume of the empty space remaining in the can. Okay, so this one here, we want the volume of the empty space. So it's all this space right here. All this space right here, all this space. So it's basically volume of a shaded region. Okay, it's all the leftover space. So what we want to do is take the volume of the cylinder. Okay, it's a can of tennis balls or racket balls, whatever. Tennis balls, racket balls. And so we take the volume of the cylinder and then subtract the volume of those balls, those spheres. All right, so we're going to take the take away, because think about it. If I take the volume of the cylinder, that's all this. There's the volume of the cylinder, all that, right? That's the space that the cylinder takes up. Now, if I just subtract or erase, right? If I erase that volume and this volume, okay, I erase those. Erasing is subtracting, right? If I erase that volume, what's left over is the volume of the air. So it's going to be volume of the cylinder minus volume of the sphere minus the volume of the other sphere. Now, both of these balls are the same. radius, so whatever this one is, it'll be the same thing. So I could just make it two of those if I wanted to. All right, so it's going to be, again, pi r squared minus 4/3 pi r cubed minus 4/3 pi r cubed again. So this is going to be pi times the radius, h, I forgot the h. This is going to be the radius 9 squared. The height is, I can't see, 26. And then this is going to be 4/3 pi. The radius of these spheres is 6. And then the same thing again. So this is going to be 2106 pi minus 288 pi minus 288 pi again. And that comes out to be 1503 pi. No, 1530 pi. And it's cubic centimeters is the units. It's always cubic because it's centimeters times centimeters times centimeters, right? It's 6 centimeters cubed. Centimeters times centimeters times centimeters is cubic centimeters. So you also have to cube the units. All right? Same thing here, 9 squared. So centimeters squared times the height times centimeters again. Centimeters times centimeters times centimeters is cubic centimeters. All right. Now, surface area is more of an Algebra 1 topic or a middle school topic, but they give us the area, surface area formula. So they might do that and then ask you to figure out the volume. We can do that by simply saying, all right, if surface area is 4 pi r squared, that's the formula for surface area, and I know the surface area is 144 pi, I'm going to go 144 pi equals 4 pi r squared. Now I divide by pi because the pi's will cancel right out. I'm also going to divide by 4. So that gives me 36 equals r squared. And then, of course, I take the square root, and I have r equals 6. If the radius is 6, I can now find the volume of the sphere. Volume equals 4/3 pi r cubed. So pi times 6 cubed. So that's going to be, I just did this, 288 pi. 288 pi, or 904.78. All right, either one. They didn't really specify, so I kind of just did both, however they want the answer. All right, and last one here. An ice cream cone is 11 centimeters deep and 5 centimeters across the opening of the cone. 2 hemisphere-shaped scoops of ice cream, which also have diameters of 5 centimeters, are placed on top of the cone, right on top. If all that ice cream were to melt into the cone, would it overflow? So this is an interesting problem. So I have this cone, waffle cone, right? I have this cone, and then I have 2 scoops of ice cream that are going to go on top. Plop, plop, right? We're going to plop 2 scoops right on top. Real life problem here. So it's 11 centimeters deep. That's going to be the height of the cone. And 5 centimeters across the opening of the cone. So that's going to be the radius of the cone. That's a 5. 2 hemisphere-shaped scoops of ice cream, which also have diameters of 5. Oh, across the opening. I messed that up, sorry. Across the opening of the cone is 5. So the diameter is 5. The diameter is 5. So diameter is 5, therefore radius is 2.5. Radius is half of the diameter, halfway across. So that's going to be the radius of it's the same radius for the spheres, all right? I know I drew circles, but just pretend they're spheres. I'm not good at drawing spheres. All right, so 2.5 for the radius. So what they're asking is, if all this ice cream melts into the cone, will it overflow? So we need to know the volume of the cone, first of all. how much ice cream the cone will hold. So the volume of the cone, and that's 1/3 pi r squared h. We did that in our previous lesson. Radius is 2.5, and the height is 11. So the volume of the cone is approximately 72. I'm going to put approximately 72 cubic centimeters. Okay? The volume of the cone is approximately 72 cubic centimeters. I just threw all this in a calculator. 72 cubic centimeters. So the cone is able to hold 72 cubic centimeters of ice cream if it all were to melt in there and become milk, right? So now, figure out how much ice cream this actually is, because it's in a solid form and it's in a sphere shape, but when it melts, it's not going to be solid anymore. It's going to melt right into that cone. So we're going to just, but it's the same volume. It's just in a liquid form instead of a solid form. All right, so we're going to do the volume of each sphere. So volume of the sphere, 4/3 pi r cubed. So 4/3 pi, and then the radius is 2.5 cubed. And that's going to come out to be 65 cubic centimeters. All right, so there's two hemisphere-shaped ice cream cones. Sorry, hemisphere. Bad picture. Two hemispheres. So we have one hemisphere, boom, like that, and then we have another one like that. All right, so two hemispheres. There we go. That makes more sense. So two hemispheres, and two hemispheres is a sphere. That's why we're doing a sphere. So two hemispheres equals one sphere. So anyways, the volume of the sphere, two hemispheres put together, is 65. So there's 65 cubic centimeters of ice cream, and the cone holds 72 cubic centimeters of ice cream. So if all that ice cream melts into the cone, it will not overflow because the volume of the cone is greater than the volume of the ice cream. So we have to explain that. It will not overflow. It will not overflow because the volume of the ice cream is less than the volume of the cone. Or you could say the volume of the cone is greater than the volume of the ice cream, right? So basically, any explanation in your own words would be good enough to show that the ice cream will not overflow because there's not as much ice cream as what the cone holds. Therefore, it'll just melt right in there and kind of sit in there like that ever happens, right? All right, so I will see you in class tomorrow.